absolutely. I'm going to focus on the database. We did a really good session yesterday, actually, like probably one of my favorite sessions so far, where we effectively went through the different like stack layers of like where data is relevant to training foundation models, and then like seeing how fine-tuned models and derivative models are trained as well. So a little bit about stability. Our mission is really around like activating humanity's potential through generative AI. We believe that giving everyone these open models and making them available to everyone everywhere will effectively allow everyone to elevate at the same rate of change. And we can do that, through effectively developing country culture models, which represent, your culture, your country, your company, and your community is going to be fundamentally important. And why we believe in open, one of the reasons is, unstoppable innovation. We see huge developer communities jumping on these models and fine-tuning them and creating huge variants of the core models. So we've won a few awards for our various models, such as Time's Best Innovation Award for our audio model and various others. We're already some of the most liked and downloaded open models globally. So we have, it's above 140 million downloads of our various models on Hugging Face now. And in the first 150 days, we were able to actually generate like 50,000 GitHub stars, which, is more than Ethereum and Bitcoin repos on GitHub. And our community is now over 300,000 just on Discord. So lots of, community activity happening. I'd say like half of those are daily active users. So lots of people like generating images and supporting each other, fine-tuning models on our Discord channel. We now started with Stable Diffusion, which most people are well known that we sort of supported bringing that to market. And now we have variants of Stable Diffusion. Stable Diffusion 3 is like a model that's coming out very soon. And that is, benchmarking better than the Midjourney, DALL-E, Google's latest image model. And then we have, variants of a Japanese image model. We have language models. Language models are really interesting. So our latest 1.6 billion parameter model, you can literally run that, on a smartphone now. It takes about 700 megabytes of like VRAM, but literally you can run it locally. Its response times is, I think, around like 86 tokens per minute. So, it's pretty fast. There was a video here, but it can't load. So that's fine. I can skip it. There were some cool videos. Basically showing you how like XDXL works, some of the things that we're working on around it. SDXL Turbo is interesting. It effectively reduces going from like 50 steps to 1 step, and allows you to inference much quicker. So now you can actually have like real-time generation of images. So you type in, generate me, a cat with a hat on a mat, and then you change it to a blue cat, and it will literally do it in real time. It's a shame the video doesn't load. Oh, because they have Wi-Fi. That will be the reason. And then we have like other models such as audio models and 3D models as well. Thanks. We can really skip with that video. You can find it on YouTube, I'm sure. Our latest like video model, we have, a lot of people basically taking the videos, generating like short form video, and then they're piecing them together and effectively allowing like machine learning to piece those different snippets of video. And the community collaboration around that is pretty amazing. So we really focused on image to begin with. So text to image, and then like variants and adaptations of image generation. So you can do like quite advanced like in painting now. So effectively, that's Ahmad, our founder, now training him to a Star Wars character. This is a UI I was playing around with on the plane actually. So you can effectively, I generated this initial image and then in-painted around, the face of the subject matter. And they said, generate me Donald Trump. And that's the first attempt that it came out with. And you can effectively have more depth in those images as well. This is quite interesting from a, storage perspective. you effectively have upscaling. So you take a low resolution image and you can upscale it to, 1024 image or 4K image without actually increasing the storage capacity. And, effectively doing that in real time. It's very good for, video rendering, very good for gaming, virtual worlds, etc. And then we have advanced upscaling, which is basically taking like a low resolution polygon image like N64 James Bond, awesome game, and then creating a new character from that initial image. And then if you're familiar with, Stable Diffusion and image generation, there's just a huge amount of community participation now from generating an initial character and then, asking it to create like a variant of that character in the same like stylization. So you can imagine effectively creating like, different NFTs and things with variation of those. Like an example here. So yeah, you take like one initial design of let's just say an NFT, and then it would create, like 10,000 variants of the same one. And you can effectively use AI to start creating like attributions and characteristics around these different NFTs. It's actually something we worked on when we first started Stability. And then more practical examples, for comic books or production, copy, and, animation studios and things using Stable Diffusion as part of their productive workflows now. As well as like imagery and landscaping, gaming companies starting to implement this, and texture generation as well. So stable code is interesting from a ecosystem development perspective. We trained stable code on like 18 of the most popular programming languages. So now, arguably, to some level of refinement, you can basically be like a developer now. Like I know very basic HTML and CSS, forgotten it a lot from university, but effectively now, you can actually create more advanced applications across these different languages just by generating code, and like half of GitHub's repo, I think, is now like Gen AI. And this is our latest language model. So averaging 700 tokens per minute, which is like 5 times the speed of a human. Reading, it can effectively churn out text and answer questions in various languages by default, and it can run on, literally iPhones now. And we now have, communities taking our initial like core models and having optimizing them to run on, like 12 gigabytes of VRAM and getting like, 1280 outputs out of it. This is, again, you can run these on your local device. So what's next for Stability? So we're really focused on now like democratizing AI technology. That's the core focus for us. And we believe, we're now in this intelligence revolution, going from a digital revolution. How do you make information, knowledge more usable, accessible, and intelligent? And building an open and transparent and fair, accessible system, and putting this technology in the hands of every single person globally, eventually, and elevating humanity. In regards to data, the outputs and knowledge retrieval of these models are really only as good as the data they were trained on. And effectively, what we're seeing now is training data. There's a lot of like companies effectively trying to acquire like data sets. They're spending hundreds of millions of dollars to acquire these like large data sets, Shutterstock, Getty, etc. And then effectively like training models on those. So the quality of data is very important. One thing interesting here is, training data. We trained Stable Diffusion. It was about 100,000 gigabytes of image data, a lot. But, stable video is a lot larger. It's probably above like a petabyte, which is, 1 million gigabytes of data. So like storing that is like challenging, right? As you go down the different stack, like how much data is required to fine tune off of like these core models is lesser. But still, the expectation is if all of us are now creators, we're going to be generating huge amounts of data. It would have taken me an hour to do something on Photoshop. Now I just say, generate me a cat with a hat, and it will generate me 10,000 of those if I really wanted to. Video is going to get more complex, and it's going to need it's going to need like just a scalable like data storage solution. So i.e. why we're looking at various options. And yeah, I think the next phase of that is enabling, like, what we want to do is like enable like a distributed intelligence system. So looking at ways that we can effectively incentivize participation of these open data sets. We think that's fundamentally important because it should represent, a company, country, culture, community, and it's the people that use these models that know and have that information and can share that information. So yeah, effectively, it's now a stage where you should own your own data, own your own models, and own your own intelligence. Thanks, Will.
Awesome. Are there any questions for Scott? Because we actually talked about this earlier. The audience of your stack are obviously model. I mean, there's inferencing, right? And you were saying like I know you didn't really talk too much about it, but you have a large compute stack as well as part of Stability AI. How can we integrate the Filecoin ecosystem in your mind with Stability AI? Because we talked about it yesterday at length, but it would be good to hear the summary and your take back to the audience.
Yeah, I think there's a few ways. So the training data, as you saw, is like very, very large. And that was one image model. We have variants of image models. All of that training data, like there's no way to really like mitigate the size of that. And it's only going to increase as, we have more like video models, like audio models. They're only going to advance. So the data requirements for us is like, we need to find a better way of, having the ability to store that. So I think there's something interesting there. And then, yeah, as I said, we want to build a system now which is not reliant on having to go and like license lots of, closed proprietary data sets. We want to build a system which enables like individuals to get utility value from the models and want to participate in, making those models better. And some of that's, gonna come from reinforced learning data, RAG data, and then looking at like how you can build like high quality synthetic data sets as well. So all of that is in need of a data storage solution.
Fantastic. Thank you. Any questions? Go, Bob.
Quick one. What's the easiest way to get started? Can you load the models into LM Studio or not?
Yep. Running on my Mac right now.
Oh, okay.
Two questions. Do you think it's practical or something that can be done to decompose or disaggregate the training compute, the compute that is run against the training data? Specifically, I'm thinking about the Filecoin use case where the public data sets that may be of utility value in training an AI model may be distributed across 100 different storage providers. Can you envision a path that disaggregates the development of those models where a small chunk of the compute is replicated across those storage providers? Second question, there was something mentioned that in the process of, say, doing a large language model training set or in the visual stuff, there are interim snapshots that are captured of the state of the model or the training inputs to that data, typically north of 500 gigabytes per snapshot. And it is of value to retain that, is what we were told. But the data storage requirements are huge. Can you envision a short-term fix where we can start snapshotting that stuff on the Filecoin for you so that you can show the progression of the training that led to a certain behavioral model at an inference engine point?
Brilliant questions. Firstly, on the training side, I think like you still require like huge amounts of compute and like high-end graphics cards to effectively have the best like optimized and most cost-efficient way of like training foundation models. So I think like distributed compute doesn't work right now for like foundation model training. Like you just need huge amounts of compute to do that. But I think on the inference side, there's something definitely that we can do that. Just because, it's effectively just like inferencing and calling the model through an API or running locally. Hope that answers your first question. Second question is the snapshot piece. That's really interesting. And I think definitely Filecoin could be used for that. It's going to get more important as well, because effectively you go down these like large model training runs and there can be issues, you know, like we've had a couple of times where we like burn out one of like A100 chips, and because there was like a solar flare somewhere or something like that. It's like pretty crazy. And effectively, if we didn't take that snapshot, you know, we would have lost all of that capacity, spent huge amounts of money on basically running these GPUs. So that for sure. And it's also important from a regulatory perspective. Like these open models, they need to be like fully auditable, you know? And from also, if you're like a regulated industry, you also want to see like how these models were trained and what data they were trained on. So I think it's going to be really important.
I want to double down on the first question.
Yeah.
Is it because our limitation in being able to disaggregate the compute that goes into building the models? Is it a limitation of IPC or RPC type connections between the GPU nodes, or is it the cost of the hardware? And I asked that, let's imagine somebody came up with a really clever way to come up with composable infrastructure that can, in software, rewire itself to be task appropriate for a variety of these kinds of GPU compute jobs. If I fix that problem, where I can have composable infrastructure that I can rewire on the fly to be optimized for your solution, am I still bounded and limited by the RPC data link between the disaggregated compute function nodes?
Yeah, again, great point. I think so far, like you basically need like interconnect between these chips. And we have like our A100 clusters on like the same spine. So effectively it just like makes it very optimized to train these models. But to your point, I think these models are getting smaller, right? Like I just showed you, like the latest language model that we have is like a lot smaller than our model, you know, even just like 6 months ago. So I think there's ways that you can effectively look at, if there's a way to do that, then sure, I think a lot of foundation model companies would be interested to see.
All right. Thank you.